All right, so what we're going to work on is creating a cube, just like we have here. We're going to place a hole inside of it. We will then go from the design to the manufacturing to be able to create a 3+2 5-axis motion. And as we go through this, I will do my best to explain all the steps from start to finish. And then when we get done with that, we'll go in, slow it down, go right back to the beginning, a little bit slower, and just kind of repetitively go through it a few times. So this one is already kind of completed. I'm going to start a new instance or a new model. By doing that, we could click the new design button plus up in the taskbar on top. Then we have our model space that opens up here. We have the green line is the Y, the red line is the X, and the blue is the Z. If you're first starting out in Fusion and haven't set up any of the preferences yet, there is one preference inside of Fusion that you'll want to set, and that is the default modeling orientation is Z up. That I think the default is Y up. So setting that Z up is good. You also, if you're coming from other programs like SolidWorks or just are familiar with how Pan and Zoom and all that works, you could set a different preference for that here as well.
Oh, nice.
So yeah, there's Tinkercad. You had mentioned Tinkercad on Monday. So say okay to that. Then we are able to rotate the model space around. So if we view it from the top, positive space is in this upper right quadrant of the modeling space. And the first thing we're going to do is come up and create a sketch. Fusion builds its 3D models off of two-dimension sketches. So to start a 3D model, we first have to create a two-dimensional drawing or sketch of that. So when we select sketch, it's asking what plane do we want to draw this on? We want to draw it on the top view. So I'm going to select and click here. We can see how they become grayed out on the selection. Then it zooms around to show us the top view, as we could see in this top right corner of the cube. And we are now into our drawing tools that we're going to use. And we're just going to draw out a rectangle by 2 points, clicking that tool and then coming down, clicking once. And then we could stretch this out and click again. I'm not necessarily worried about size on when I'm dragging that out because we're able to set dimensions and constrain it to a dimension. So if I want to have this at a specific size, we'll use the dimension tool. Gonna click on the line that I want to dimension, move the mouse out a little bit, and then specify the size that I want that to be in the Y direction. We could do the same thing in the X, and we'll enter a 5x5 cube or square. Once we have that finished, we could click Finish Sketch. Just going to rotate that around a little bit because we're going to take this sketch and extrude it in the upward direction by using the Extrude tool. And it was already selected, so I'm going to escape out of that. So right now, if I hit the Extrude tool, it just happens to be that that sketch is selected. If you had multiple sketches, you would have to select and click on the inside of that sketch, not necessarily on the lines, but inside of the closed shape. We could now use the arrow to extrude that out, and we could also specify the height that we want this to be. And now we have a 5x5 cube. We could modify and extend and extrude that up a little bit more as we have the timeline across the bottom. The timeline are all the operations that you have used in the creation of this model. So we only have the sketch and the 3D extrusion in here. So if we want to change the height of that extrusion, you can double click on the extrude here, and then just come up and change the distance if you want that to be different. So we now have 6 inches extruded up. And the next step that we want to do is create a hole or a indent into the face of this cube. So to do so, we are also going to use a sketch, only this time, instead of selecting a plane that we want to sketch on, we're going to select the surface of the face that we want to apply or have that circle drawn on. So selecting that face, again, rotates it around. This time we're on the front side of that cube, coming up to the top to draw out a circle. And click once, drag the size out, and click again. To set the size of that circle is just the same way we set the size of the square or the rectangle that we drew, using the dimensions, selecting the circle, and then drag out. We could set that to an even 2 inches, and we'll come back and show how to move around and constrain that a little bit better after we quickly go through the first step. So I'm now going to finish the sketch. And now when we have that circle there, we could select inside of that circle, it goes grayed out, or we could select the outside and it is able to see and distinguish the two between the circle and the outside. So we want to extrude, and it's an extrude cut that we're going to do. We're going to push this into the cube. So I'm selecting the inside of that circle. It should go blue, selecting the extrude tool and that arrow, putting it inside. And since we're going into the part that is a negative value, so I'm just going to put in minus 0.25, then enter. We now have an indentation into the face of that cube by 2 inches, or by 1/4 of an inch. That is about all there is for the modeling of what we want to do. We want to move into the manufacturing side to be able to cut this and be able to prepare the code for cutting on the ShopBot 5-axis. And we are going to be using what is called 3+2. 3+2 is where we are going to first orient the A and B axis to where the spindle is going to be positioned horizontally to be able to come into the side of this face. Once the A and B is positioned there, we will then just use X, Y, and Z motions to mill out the inside of that cube or the inside of that circle. So to go to manufacturing tab or the manufacturing side of the software, we're able to change the workspace from design to manufacturing. We could now see that the model space pretty much stayed the same, but we now have different icons across the top of our ribbon. The first thing that we want to do is set up what machine we're going to be using and how we're going to be cutting. We do that under the NC program button here. If we click that, the post processor, if this is the first time you're setting it up, you may not have anything there at all. So what you would do is select from a library, click the open, scroll down through the list, and you will be looking for the ShopBot Open SBP. Once you have that selected, you would hit select, and it will place it just as I have mine here. We then need to go over to the configurations. By default, all of these operations will probably be closed or collapsed as they are now. So the first one is the configuration. This is where we are saying that, yes, we are using the newer version of our control software. The B axis does not rotate around the X. That is for an indexer operation, not 5-axis. And we want to have the 5-axis checked. We will then scroll down to the multi-axis, the gauge length. This is the distance from the center of rotation to the end of the threads of the shaft of the spindle. This number could be found in your My Variables file, found in the C drive of your computer, then SB parts, then custom, then there is going to be a My Variables file. I believe on that machine there, it measured 6.2 something. I can't remember exactly what it is, but this is a number that is written there. You might want to take that number and put some sort of plaque or something on the control box that says the gauge length is this. So other users will know, and they won't have to dig into the programs to be able to find it. So once that is all set, you would come down and click OK. Then we need to create a setup for this project. The setup is where we say what the stock size is, how we're going to be milling this, and just kind of basic setup. So we would click the little arrow, or by default, the two icons that you're going to use the most is this setup and the NC program. So setup is the same as clicking this down and new setup, or clicking that button there. So the setup first is, where are we going to set our machine origin? Typically lower left, 5-axis. It really does not matter, even on a 3-axis. It doesn't matter where you set the machine origin or where we're telling the machine origin. The only thing that matters is whatever you tell the CAM software, you have to do the exact same thing on the machine. So right now, X, Y, and Z, where it's positioned now, says that we have to zero X, Y, and Z to the top center of our model or on our part. Typically, most will do to the lower left. So I'm just going to come down and click this lower left dot. That then moves X, Y, and Z down to the lower left. This is where we will zero the X, Y, and Z on the machine. The next process is coming over and clicking the stock. The stock is what is the material that we're going to be cutting this out of. A couple ways of doing this. If we are just milling out the circle and we know the material is already set to be 5 inches X, 5 inches Y in height, all we're doing is taking this finished block, putting it on the material or on the table, and setting it to be able to cut this circle. The stock side offsets would be 0 in both directions and the top. If we were also needing to face off of those, we might make those a little bit bigger and specify the exact size of our material by doing it as a fixed side block. We will come back to that after we complete this first process. Once all of that is set, we will come down and select OK. We are now ready to create a 2-dimensional pocketing. So even though we're working with 5-axis and we do have some like 3-axis moves in here, it's still going to be considered a 2-axis milling operation, because it is going to go into the circle and then just do 2-dimensional milling on the face of this selected circle. So under the 2D operations, we're going to select to do a 2D pocket. The little fill-in sheet opens up for us to be able to select what tool we're going to be using and what feeds and speeds. I'm going to come in and select the tool. And I don't have a tool set up in here, so we're going to come up and click New Tool. We're just going to use a end mill. You could put a description in here. We're just going to go 1/4, and you could get more descriptive with it for the cutters that you plan on using. Going over to the next tab, tells us what type of tool it is. It is an end mill. The units are inches, spindle. All this is pretty much not used other than just informational, other than the units is used for setting this down below. So with every text box you click in, the graphic changes and shows you what information it is looking for. So when we click on diameter, it is looking for the diameter of this cutter, which we are going to say is 0.25. Come down and click the shaft. That is the upper side of that, which is also going to be 0.25. The overall length, this is the length that is also inside of the spindle, not used within the software at all, other than just so it knows that just has to be greater than the overall cutting length. So I'm just going to put in a value of 3. The length below tool holder. This is an important number, and this is the value you're going to get off of the machine running a file on the machine that is called get tool length. And I believe we set that up in the custom cuts menu. I'm not going to say the number, but if you pull down custom cuts, you will see get tool length listed there. And that is the item that you would click. Goes through the process of touching off the bit that you have put into the spindle off of the side plate, and it is going to report a dimension or a value. That value is what you're going to put in here for the tool length. Just for demo purposes, we're going to put 2 inches. The shoulder length, again, not used a whole lot other than with warnings. If you try to set it to cut too deep, it'll say, hey, you've used too much of this cutter to make into here, and some collision detection will happen. But essentially, this is a value used if there is a transition from a wider shanked bit down to a smaller shanked bit. And then the flute length, this is the cutting length of the actual cutter. So typical 1-inch cutting length. And the graphic on the right here kind of shows what is happening as we change these numbers. So we could see the yellow here, that is the actual cutting length, the percentage of that bit that is going to be used for and capable of cutting. So once we get that value done, we will go ahead and hit accept. With that tool now listed there, we can click select, bottom right. We now have our bit that is listed here. We would then want to come down and change the values that we want to cut. So 5,000 RPM is not correct. We'll set that to be 12,000. There is a surface speed that is used for calculating different materials. You could learn more about surface speed because just changing this one number could also change the feed rates. So if we want to cut, I'm just going to bump that up to 120 inches per minute, which is 2 inches per second. Once you get the feeds all calculated in there, the next tab is going to be the geometry. This is what are we going to be cutting? And we want to select that circle, the inside bottom face of that circle. Right now, the X and Y position is positioned from top down. So it is not able to get into this position. So we now need to orient the tool length or orient the tool. So selecting tool orientation. And we are going to set the Z axis plane and going to select the face of this, or you could select the bottom, anything that is going to orient the Z to the face here. And notice that we have our XY trident here. Right now, Z is coming down from the top. Once we select this, the Z is now coming from the right side. Once that is done, we're able to come in and select our heights, which are the material is the blue, that is like the starting height. Then we have the green, which is a kind of a retract from one position to the other. Then we have our red, which is just kind of any clearance heights from when you're moving from one operation to the next. Right now, the defaults are looking good. The next tab over is for the passes. We'll get into more detail a little bit later, but if you understand what's here, you could just go ahead and change things now. But we're now ready to just go ahead and click OK. And this is going to calculate our toolpath for the circle. It looks like I lost my selection for the geometry from when I was clicking around. So I'm going to say OK. And we now see that we have cut out the geometry and our toolpath is placed there. There is a right click and we could generate a simulation of what this is going to look like when it's cutting. You could slow that down as well. You can see the bit is moving there as we speed that up. If you're happy with the way that looked and expect to have that be the way it's cut, we're ready to save out the toolpaths for the machine, and that is right-clicking on the setups and clicking post. Now we're still in the simulation, so I apologize. So we have to exit the simulation and then right-click setups and then post. So just to point out what happened again, and you will probably find your same situation because you will and possibly simulate it first. And we're not going to have the option to be able to post this out until we exit the simulation, then come back into setups and click post process. The location of where this file is going to get saved is in the output folder. The name of the file is going to be listed here. We also have the same setup that we had way back in the beginning to generate a 3D, or we are running an SP3. It is a 5-axis part. The gauge length is 6.3 and the safe retract distance is 2. So once you have everything set there, select post. We now generated the file and it shows us that the post was successful. So we could come down and open up that file, which is under Documents, Fusion 360, NC Programs, and we have our file listed right there. And how do we know this is a 5-axis positioning move? Line number 11 shows that it is a J5. X, Y, and Z are blank, meaning that X, Y, and Z are not moving anywhere. The positional moves are for the A and B axis. So the A is moving to a -90. The B is rotating to a 90, which is putting it perpendicular to the face that we had selected. And then after it positions itself, it goes into just straight 3-axis motion to create the cutting that we have generated here. So that is the overall view of how to create a toolpath in the side of a cube. So let's pause here and see if you guys have any questions.
Let's see. I think I'm okay right now, Ryan.
All right, so we're
I don't have any questions either.
all right, great. So we're going to step back into the design. So right now we're in manufacturing. Going to go back into the design. And we're going to look at changing this sketch up a little bit to create another, not a rectangle, but a clip a corner and place a hole off of a different orientation. So to do that and change up the 3D model, remember everything in Fusion and all the models are based off of sketches. Our sketches are listed here. Currently, we're going to have two sketches. One is the primary sketch that we use to create the block. The second sketch that we have here is creating that circle. So we're going to modify the sketch one, and I'm going to right click and select edit sketch. Just going to draw in a line, hitting escape to finish that line tool, using the scissors button, and hover your mouse over top of the line, and it highlights what is going to get trimmed away. And we now have a clipped corner. And finish this sketch, we can see that the model in extrusion has now been modified to that clip that we had. And I'm going to create a sketch off on this angle here by clicking create sketch. What face do I want, or what plane do I want to create this sketch on? Rotating the model around. It takes and views that, and we can see the little cube up here, how it's oriented. Again, we're in the 2D sketches. This time, let's just draw out a rectangle. Then finish this sketch using the extrude. And I want to extrude inward by 0.25.
Oops.
There is not 0.25, minus 0.25. And set that to cut. And we are okay. So with that done, we could jump right back over into our manufacturing. And our setup is already completed. So we don't have to go through the setup process again because it is already there. Our toolpath for the circle is still listed there. But now what we have is we're in a case where we have some material that we would possibly need to remove first before we could cut out this. So we are going to do two operations here. One that is going to face off the corner of our cube or our material. Then we will set up another operation to pocket into the rectangle that we just drew. Under 2D operations, the first one I'm going to do is a facing. That facing is able to go around and just face off that whole side there. The same tool is selected from the last time we were here, along with the feed rates. Coming over to the geometry, this is asking what do we want to toolpath, and sometimes it is a bit tricky to select the right faces that we have here. One of the issues that Fusion kind of has. So let me first try to see if I orient the tool differently and see if then it allows me to select that face. So I'm going to do the tool orientation, going to reposition the Z and selecting that face. We can see the Z is now pointing, coming in from this direction, which is good. Now let's see if we can't select that face. There we go. So it was able to see that we weren't able to really get to that face with the tool orientation the way it was from top down. So now it can. So now we're going to select that face. You can see our all of our height retracts. And you see, these are out a little bit farther. And that is because, you know, the intersecting point of that cube is out here. So that is looking pretty good there. So I'm just going to say, okay. Once the messages stop popping up, we now have the facing on our block. Then the next process is creating a toolpath to pocket inside of that. And again, it's a 2-dimensional pocket. The tool and everything is set up exactly as it was for the circle and the facing. The tool orientation and the geometry is next. So lesson learned, let's set tool geometry first to this face here. See that Z moved around. Going to the selected geometry. The back face of that pocket. Again, just verifying heights. Now this is where we might want to change this a little bit, since we've already cleared out and faced that off. You could just move those in a little bit closer. And once you have all of those planes in the cutting distance and everything set, is coming down and selecting OK. Is now going to pocket that out. Once all of that is complete, again, you could come in and simulate the process. After it's completed the hole, it rotates around and faces and then it will pocket the inside of that rectangle.
Nice.
And to post this out to the ShopBot to be able to take the file, you first have to exit the simulation, right click on setups, post process, and I am going to overwrite my existing one and select post. So now we have a file that is a J5 minus 90. We will have another J5 move. And I just did a find J5. And now we could see that the B is still rotated parallel to the table or perpendicular to the face, the top, or parallel to the top face. But the A axis is rotated at 48.43. And that is the angle that is that we just randomly drew that clipped corner. And then from there, it is going to go through the facing as a 3-axis motion, facing all of that off. And farther down in the code, we will have the rectangle. Any questions on that one?
No, I'm good.
No, I'm good.
Thanks.
All right. So that is creating dimensions on going into the product. Let's just going back to the design, and we will draw a rectangle or a circle off of this face here. And instead of pushing it inwards, we are going to pull it out by 1/4 of an inch. With that design done, going back into our manufacturing. Now, this is where our setup has changed a little bit. We can see the model has gotten a little bit bigger. Our stock automatically got bigger because our model is also bigger. And that comes into the setup under stock. We can see that the Y dimension is now 5 1/4 and not an even 5, it's 5 1/4 because we added that 1/4 inch to it. So we'll say okay to that one. And now, same process as we've been going through. We're going to do a 2-dimensioning pocket. Tool is still selected from the previous operations. The geometry that we want to do, we first want to set tool orientation to this face here. Then select the geometry. I have to hit the Z axis because that's what we're orienting to this face. Z is coming from, it's pointing to the where positive direction is. So that is coming in from the way the arrow is pointing. That is looking good. Now we want to select what we want to face off and pocket out. Our heights again are looking right where we would want them to be, and just come down and click OK again. And hopefully you saw what mistake I made, and I will point that out once more. I selected only that face, and it's like, wait, there's other geometry in that way. So I got an error that it wasn't happy about. So I selected the outside rectangle, holding the shift key down, selected the circle as well.
Oh.
To say, okay, so now it sees that we are cutting within the inside, pocketing with inside of the rectangle. And since we also had other geometry set to the inside of that, it says, oh, you don't want to cut into that. Let's cut onto the outside of that. And as we can see, it is cutting around the face of that circle. And again, posting out is exactly the same way. Right click the setups and post process or simulate, and so that is kind of the process of going from design to manufacturing. Now, there are a lot more powerful things within Fusion that we're able to do, and with these sketches, just to show a little bit about how to constrain and a little bit more into the design of Fusion. This is the sketch for this circle. So I'm going to right click and select Edit Sketch. We're able to dimension this sketch and constrain it to other aspects of this cube. So I want to have, if I want to have this circle always remain, regardless of the size of this cube, centered in this cube, I'm going to draw a line, and then setting the line type over here to be a construction. And we're able to snap that line to the edge of that cube, coming in, and it snaps to the center of the circle. Then again, snapping to the outside edge. Those lines right now can be moved around in that circle. You can see those lines are kind of attached. As I move the circle around, they stay snapped and centered on there. That is very useful for when we are able to constrain them. So these are horizontal constraints. So if I always want this line to be horizontal and not allow it to be angled like that, I'm going to select that line and select the horizontal. And we see how that now snaps perfectly horizontal. And when we move this around, the other side is staying at its angle, but the one is horizontal. Do the same thing for this line. And again, moving that circle around, both those lines are now staying horizontal. And that circle is only able to move left and right over top of that line. But now the real power comes into other constraints. I'm able to say that I want this line holding the shift key down and this line. I want both those line segments to be equal to one another. So we have an equal constraint. That now means that when I go to move this, I cannot move that circle left or right. I could only move that up and down.
Nice.
We can now use the dimension sketches to say that I always want the top down to be 1.5 inches, and we are okay. Now notice that circle was blue. It is no longer blue, it is black. And what that is saying is we are now fully constrained, and we are not going to be able to drag this circle around anywhere because we've rigidly locked it into place to say it is equal centered here with a distance down from the top of 1.5. And the reason this becomes very powerful is when we finish this sketch, and if we ever change the extrusion height or the size of this, so let's change the extrusion height first. And instead of 6 inches, let's make that 12 inches, and we'll say okay. That circle now is still 1 inch down from, or 1.5 inches down from the top of that, regardless of what size we made that extrusion. And the same goes for the right and left. So if I modify this sketch, instead of 5 inches, let's make that 10 inches in that direction. It's a little too big in that angle. Let's make it 7 inches. And we'll finish that sketch. And with that equal constraint, that circle is still centered within the width of our model.
Nice.
Now we are going to, since we've changed the design, when we go back into the manufacturing side, we might see some, we did all right. It automatically recalculated already. Sometimes these lines here tells us that we are having problems and it recalculated for us and we are all good. You would just have to resave the toolpaths out, but as we could see, the it did not update by itself. So that's a good reason to come in and regenerate toolpaths. And I am not in simulation. Could generate, which goes through and recalculates all these toolpaths and repositions them to our new model. So when we simulate this time, we could see that they're up there where they're supposed to be now. So remember that we want to have, it did tell us that we had errors and issues. So the yellow there, we want green check boxes in our setup. I'm not quite sure what it's asking us about here, but it's saying that we just need to resave because our stuff was out of date because we've moved things around. But essentially you want these green check boxes to be there. And that says that the tool pathing that is generated is and does match up to the geometry.
Hmm.
So hopefully this is helpful, and with it being recorded, I think you'll be able to rewatch it. Any questions that you have?
Um,
No,
Remind me again how you did the angled corner. I know you cut it off with the scissors, but did you draw a
Yeah.
line just across the top, the one sketch?
Yeah, so that is the sketch. The very top sketch is usually the base sketch of the model. And that sketch is drawn on a XY or some sort of plane. So I'm going to right click and select to edit that sketch. If I wanted to clip another corner or change the geometry or the shape of this, we could modify anything that we want here. So I just randomly drew out
Line, yeah.
a line and use the scissors, clicking the scissors and come down, and you can see when you hover over top, it
Mhm.
changes to a red. That is what is getting trimmed away. I'm getting warnings down here that because it's like not an open shape anymore, it's going to get confused on what to do. So once
Yeah.
we close that, we're all good. And notice that my one dimension has gone away because it can't constrain that anymore. So we might want to set constraints differently. Just as we had on the one sketch, we could, dimension this as well, to where I could say set an angle
Oh,
and constrain this one as well. And we have all of these are blue lines out here still. That just means that we're not fully constrained, which in your world that might be okay. But it's nice if they were all black lines, meaning that when you go and move things around, things don't change. So
right.
when you see how things are, like the lines aren't going quite where we wanted to be. So just load it up with more dimensions and kind of lock it in place to where it is constrained in a way that when you move it, it just is going to kind of lock itself into place.
Yeah. Hmm.
So I got an error there that it was going to be over constrained, and that is this angle, and the size of that is constrained by the dimensions, those 3 dimensions there. So
Hmm.
there's a lot more to fusion in all of this. And as we progress through our next video, we'll be learning more about sketches and how to constrain them to one another.
Nice. Very, very cool. I'm just gonna need a lot of practice.
Yes. All right, so I am going to hit our stop recording.